let's not waste time because time is of the essence. Thank you for that. What you just heard was an introduction and a demonstration to show to you the importance of chronological order, correct chronological order. If I play the notes of any bass line in a random order, the melody, the feeling, and the groove does not come across. But if I put all the notes in the correct order, and all the credit for the bass line you just heard goes to Flea of the Red Hot Chili Peppers, the melody is clear and you get the groove, and showing that you can get the structure. So I ask you, why don't we use the advantages of chronological order in 3D BIM models? Why don't we have chronological models? My name is Albrecht Vaatz. I work for the DB Bahnbau Gruppe. This is German for German Railway Construction Group, and I'm a PhD candidate at the TU Dresden. We already finished the first point of my agenda, so let's go over the rest really quickly. I will talk to you about the motivation of our work and the related problems. Next, I will show and explain to you the concept of chronological models, or CMODs. Then I will get a bit into the details of realization and present to you the core element of CMODs in its current state. And I will finish my presentation with a little outlook of what possibilities might be lying ahead. So let's start with our motivation. The problem we face is that modeling and planning is very time-consuming, and because of the amount of information needed is so enormous, and so is the effort to collect this information. What is our goal? We want the perfect BIM model, nothing less. And by the way, it may look like something like this. You will see what I mean at the end of my presentation. So what are possible solutions to get there? How can we save time working with ASC-related info? I believe, first of all, everyone needs to be able to access and contribute information, so compatibility is crucial. Secondly, models should be complete, so all necessary info is integrated and kept in the model. I also believe that keeping track of the chronological order of events, data, and info is very important, so the timeline plays a big role as well. And lastly, I'm sorry, I forgot to skip here. And lastly, the consistent use of models in all stages of the life cycle of a building or component ensures that the info will not be lost and reduce the need of data procurement effort. My thesis is this: time is a critical factor for the cost of ASC-related projects and the fundamental category for putting information into a logical structure and context. Chronological models, or CMODs, can store and structure temporal information of all model-related data and make consistent model use possible. Now, let's have a look at our concept. These are the basic components of our concept of chronological models. We use IFC as a modeling format and information container for linked document delivery, short ICDD, to link all related data to our IFC models. Also, the ICDD is used to utilize ontologies, such as the bot, dot, or time ontology, and add semantic knowledge to our models. The ICD acts as both data storage container and link of different models, ontologies, and all sorts of data. What we added is a way to use dynamic links for ICDD, making the versioning of links obsolete. This topic will be presented to you by my wonderful colleague Nidhal Al-Sadoon in a separate paper presentation in this conference tomorrow afternoon, so please make sure not to miss that. Our second edition is the Ontology for Chronological Construction Processes, short the OCCP. This is the core component of our CMODs, and I will show you what it is after rounding up the general concept of our chronological models. Here you can see the concept overview of our chronological models, and I will go through it quickly and step by step. We start off with a basic IFC model, and this is crucial. We use a geodetically defined, consistent area model of a region. Basically, we model the plot first, or use an existing model. We collect all model-related data, and in the case of this area model, this could, for example, include subsoil survey data. The model-related data is connected to the consistent area model using ICDD, serving as a link. As mentioned before, the ICDD is used to implement ontologies for the semantification of the info provided by the model and the model-related data. Then we add our IFC construction model and link it to our consistent area model, symbolized by this little white diamond right here. So looking at our perfect model, we start with the area model. Next, we add a construction model of building A. And to that model, we add all associated components, such as the basement F. These components right here represent the basement. We have the foundation, the armoring, and the walls. And we can add more components as needed, of course. All components are linked to the construction model, but each component exists as an individual model. So in fact, we pick up on the philosophy of modular models. Thinking back to our motivation and proposed solutions, we have taken care of the first 2 points. Compatibility is not an issue due to the use of open source formats, and they help us putting all information needed into our models so they are complete as well. But how can we handle the timeline? We handle the timeline by implementing the OCCP, again using ICDD. Now I will show you what the OCCP is and what we do with it. OCCP is the core element of CMODs, and it's based on the construction life cycle. The construction of the life cycle and the structure of the life cycle, you can see on the right, consists of phases and transitions between phases. We start with the planning and review phases, and with the acceptance of the final plan in the review phase, the planning is completed. Then the tendering process starts, and it ends with the submission and construction and the construction phase starts. With the completion of the construction, we have several parallel phases: usage, warranty, design life inspection, special events, damage, repair, and maintenance. And after that, the deconstruction decision marks the transition to the deconstruction phase. The OCCP is an addition to the time ontology by Simon Cox and Chris Little. It expands the time classes by defining phases, as you can see on the right. And for each of these new phases, several instances are defined as time instance. For example, for the planning phase, we have the instances beginning of planning, data procurement, edit phases, before and after the submission to review, so that's ASTR and BSTR, and the submission to review itself. Of course, we expand the time object properties as well to structure the classes. And with our new classes and object properties, we can now semantically structure the temporal information. This means that for each component of a construction, each piece of information can be assigned to a specific time phase and/or time instant. So for each component, we know the individual history, we know the chronological order of events, and can keep track of all related data and information. Currently, the OCCP is work in progress, and we hope to receive feedback from you and the AEC community to assure that we are on the right track with this. So if you have any suggestions, critique, or feedback, please contact me or find me later on during the conference. The release of the ontology is planned for later this year. Again, looking at the list of our solution approaches, we find the timeline is taken care of. How we can work towards the consistent use of models, I will demonstrate to you in the Outlook. Imagine a video player app like you use on a computer. Using a slider, we can skip to each section of a movie or skip back if we missed something. We want to apply a somewhat similar functionality into the software we use to work with 3D models. Again, we start with our consistent area model as a basis at the point in time called T0. Next, the construction A, including the basement F, is added to our consistent area model at the point in time T1. At T2, building B is added, and note that each building is assigned to its own point in time, while of course things could happen simultaneously. At T3, we add building C, and this can go on indefinitely. I think you get the point. What's special about this is that all the life cycle information for each of the constructions and all their components are stored within the OCCP and connected to the consistent area model. And this information could be kept indefinitely without causing contradictions in the model. Let's take a look at T4. At T4, building A is deconstructed, but the basement F is not, and thus remains in the area model, or to be precise, it will not be assigned a date of deconstruction, so it will continue to be displayed in the model while focusing on T4 and onwards, while it is until it is deconstructed, and therefore receives the corresponding entry within the OCCP. That way, we can consistently use all model information, and by choosing a specific time frame, we filter all relevant model data that is to be displayed. We hope to significantly reduce the loss of information and save time collecting all information needed in any phase of a construction's life cycle. At T5, it starts to get really interesting. We add another building, building D, on the same location as building A. Due to the difference in time, placing them in the same place within the same consistent model is no longer a problem. The same principle can also be applied to difference in phases, so we are no longer forced to ensure the space-related freedom of contradiction, meaning within CMODs, several elements can be at the same place as long as they are separated in time. And we just have to make sure that they're not at the same time and at the same place simultaneously, because obviously that usually hurts, right? So before I finish, here's a short summary and some final thoughts. What makes a CMOD unique? Well, all information that is either embedded in or linked to a model is chronologically correct. But not only that, all temporal information is semantified by our ontology for chronological construction processes, the OCCP. Also, CMODs are modular, and all models and submodels are embedded in a consistent model. What can we do with a CMOD? CMODs enable a consistent use of models, which prevents data loss and helps to get a better understanding of our constructions, and it makes analyzing the model data easier and expands the time perspective. We can analyze and evaluate different types of constructions, materials, companies, processes, and so on, and it has the potential to solve legal problems as well, as it will be easier to answer the question of time schedule-related questions of responsibility. All in all, we hope that CMODs will help us save time in all lifecycle phases. Finally, what can you expect from us in the future? We will finalize and publish a first version of our OCCP and develop a minimal viable example to demonstrate the functionalities of a CMOD. And of course, we will try to find a solution for your requests and an answer to your questions. A big thank you goes out to Nicholas Fragiadakis for lending me his bass guitar and amplifier. I would also like to thank the EC3 Orga team for helping me to make my little introduction possible. And with that, I thank you very much for your interest in this topic and your kind attention.